In the first question, we know that x tau is WSS and it is real. And so we can know that the autocorrelation of x x tau it equals to the expectation of xt plus tau and multiple xt. And because x tau is real, so we can find that this part is also real. So the rxx tau is real. And then we can write rxx tau it equals to r xt plus tau t, and then it equals to the expectation of xt plus tau and multiple xt. And then we can write it into this format. It equals to xt multiple xt plus tau, and this part it equals to rxx negative tau. And so we can find that the rxx tau it equals to rxx negative tau, and so rxx tau is even. And in the B question, the sxx omega, we can using the definition to calculate. It equals to the integral from negative infinite to infinite rx x tau and multiple e to the power of negative g omega tau d tau. And then we can split into two parts. It equals to the first part is the integral from negative infinite to infinite rx x tau multiple cosine omega tau d tau and minus g multiple integral from negative infinite to infinite r x x tau multiple sin omega tau d tau. And we can find that this sin omega tau is an odd function, and the rx tau from the A question we know that it's an even function. So this part it's an odd function, and because the integral interval is from negative infinite to infinite, so this part it equals to 0. So the first part, so the sxx omega it equals to integral from negative infinite to infinite rxx tau multiple cosine omega tau. This place should be omega tau it equals to cosine omega tau d tau. And then we can and because the cosine omega tau it is an even function, and this part is also an even function, so we can write it into this format: 2 multiple integral from 0 to infinite rx x tau multiple cosine omega tau d tau. And because it is cosine omega tau is it's an even function, and this part is also an even function, so we can also write it into we can also write it into this format. It equals 2 multiple 0 to infinite rx x tau multiple cosine negative omega tau d tau. And so this it equals to s x x negative omega. And so we can find that x x x omega it equals to s x x negative omega. And so we can find that the sx omega is even. And we want to show that the ss omega is non-negative, and we let xt pass the filter h omega, and we let h omega it is when it is between when omega is between omega 1 and omega 2, we let it equals to 1, and otherwise we let it equals to 0. And we can draw the and when xt passes this filter, we can get yt, and then we can calculate the expectation of yt to the power of 2, and it equals to 1 divided by 2 pi, and we can use this is formula. It equals to the integral from negative infinite to infinite h omega to the power of 2 and multiple s x x omega d omega. And from this expression, we can know that when it is between omega 1 and omega 2, the h omega it equals to 1, and otherwise it equals to 0. So we can write it as this format. It equals to 1 multiple s x omega d omega. And then we can, and because this part it is larger or equals to 0, and so we can find that s x x omega in any integral in any interval, the value of 1 divided by 2 pi integral from omega 1 to omega 2 and sx omega d omega is non-negative. Yeah, this is because the expectation of yt to the power of 2, it is larger or equals to 0. So this part it is larger or equals to 0. So this part is non-negative. And because it is it should be satisfied in any integral, so sx omega larger or equals to 0 everywhere. And this is the first question.